In this second example, we need to design a low-pass Chebyshev filter type 1 based on this specification. So first, we determine the discrimination factor based on attenuation passband and attenuation stopband value. So we note that the omega passband is equal to the omega cutoff. So we can use this value to determine the selectivity factor. And the next one, we determine the filter order based on the discrimination and selectivity factor that we have calculated in the previous slide. So we rounded this value, therefore n is equal to 3, and we choose T3x from the Chebyshev polynomial table. We have this equation, so we determine this function based on this x value. Okay, so we plug in this one into this equation. So we have this one as T3x. The next one, we determine the T3 squared based on this function. So we have this 6th order polynomial equation. The next one, based on this equation, we determine epsilon squared using attenuation passband. So we substitute the value of epsilon squared and T3 squared into this equation, and after we rearrange this equation, we have 6th order polynomial. And the next process is you need to factorize as we factorize the 4th order polynomial equation in the previous example. After we factorize this denominator function and determine all 6 poles of this function, we select only left hand side poles where left hand side poles have negative real value. Okay, so this is all the negative real value. So we have 3 hand side poles. The next one, since n is equal to 3 and it is odd, so we use HA0 equal to 1 for this function, and we calculate based on the all 3 poles that we have select. So this is the first left hand side pole, second left hand side pole, and third left hand side pole based on this equation. And after we calculate this one and settle, we have this as the transfer function in S domain for Chebyshev filter. For further reading, please refer to the monograph based on the Chebyshev filter subtopic. With that, thank you very much.